Given a quadratic equation as x squared minus 3kx plus 2k squared equals 0, where k is a non-zero constant. Okay, so we have that unknown constant k in there. Well, we know it's not 0, but it could be anything else. And we're asked to show, for this quadratic, one of the solutions, or the roots, or the x-intercepts, is twice that of the other one. So a few ways we could approach this. We could find the solution using the quadratic formula. Find both solutions using the quadratic formula, and it would hopefully show that one of the solutions is twice that of the other. So it might be in terms of k, but that's fine. Or we could factorize it to also show the same thing. So let's do both. I'll factorize first because that's the easier way if you can see it, but if you can't, the quadratic formula is definitely a go-to. So this one's a bit tricky because k, we don't know what it is. So we have to rewrite the quadratic equation. The quadratic equation out. And we're trying to find two numbers that multiply to 2k squared and add minus 3k. So to get 2k squared, we know both of them must have a k in it. Right, if one of them had a k squared and the other one didn't, then we would have the group-like terms. So we know at least there will be a k in both of those numbers. So to get to 2, we could do 1k plus 2k. But you'll notice when we expand that out, we'd get plus 3kx. So to get minus 3kx, we must subtract. And let's just double check. X times x, x squared, x times minus 2k, minus 2kx, minus k times x, minus kx, minus k times minus 2k, plus 2k squared. So that checks out. Okay, so we haven't found a solution yet. We've factorized it. But since this equals 0, we know that both sets of brackets could be 0. So if x minus k equals 0, x would equal k. Or if x minus 2k equals 0, x would equal 2k. Therefore, in this case, 2k is twice the other solution. In this case, k. So that's one way of solving this problem. The other one is if you're a bit rusty on your factorizing, especially with these unknown constants, you can use the quadratic formula. So this is in your data booklet as negative b plus or minus the square root of b squared minus 4ac over 2a. Where a is the number in front of x squared, b is the number in front of x, and c is the constant. So plugging these in, negative b, negative 3k. Right, so I need to be a little bit careful here. The k is a constant, right? So b is the constant in front of x, negative 3k, plus or minus negative 3k squared, minus 4 times a, which is 1, times c, 2k squared. That's all square rooted, right? And we call this bit the discriminant, actually. over 2 times 1. So that looks pretty messy, but it'll simplify down to the same solutions we got before. So let's do that. Negative 3k. So there's actually a hidden times there. So when we times two negatives, that becomes a positive. Plus or minus negative 3k squared will become positive 9k squared. Minus 4 times 1 times 2k squared minus 8k squared. Let's just do an extra step here. So 9k squared minus 8k squared is k squared over 2 times 1 or 2. Square root of k squared is k. So 3k plus or minus k over 2. And the plus or minus, so that's giving us our two solutions. So our first solution could be x equals 3k plus k over 2, which is 4k over 2, or 2k. Or it could be x equals 3k minus k over 2, which is 2k over 2, which is k, giving us the exact same solutions as the factorized method. So our conclusion would be the same.